Hello everyone, welcome back to the Math 0332 channel. I'm Mr. Lee, hello. And we're starting our last full unit, Unit 6. So this will bring up something that we've talked about a little bit in the past when we did the prime factorizations at the very beginning of the class. There's some aspects of it that affect how we can clean up square roots. Now, I like to call square root basically jail for the numbers. You have to have a pair, so you have to have a friend who's the same as you to distract the guard so that you can get out. So when we're simplifying square roots, we're really looking for pairs of common factors so that one can get out. Now, one thing to remember is that, for example, the square root of 2 squared is 2. So every time that you can find a pair, it allows one of them to escape. But we had 2 here, and there's only 1. I like to say the other one distracted the guard, and nobody knows what happens to him. So if you wanted to do the square root of 540, for example, how I would do it is I would break down the factor tree and then look for the potential pairs. You might say that this is 54 times 10, and you might know that 10 is 2 times 5, and once you get to the primes, you're done there. For the 54, there's a few different things that multiply there, but it's still even, so we'll do 2 and 27. 27 will break down to 3 and 9, and 9 breaks down to 3 and 3. So what I like to look for is pairs of numbers that get out of the square root. Here's a pair of 3's, so that means 1 3 will get out. Here's a pair of 2's, that means a 2 will get out. If it doesn't have a pair, and even though there are 3 3's, this one doesn't have a second one to pair with, they stay under the square root and get multiplied together. Everything that gets out ends up multiplied together in front, so 3 times 2 is 6. Everything that doesn't get out stays underneath and is multiplied together as well. Now, if you ever use view an example on the homework, they're going to do it a bit differently. But I don't like the way they do it. They like to basically decide what's the biggest perfect square that multiplies into a number. But that requires you to know that 540 is 36 times 15, and then to recognize that 36 is 6 times 6. One thing to note, even though 6 can be broken down further, the moment you find a pair, that is totally fine. You can take it out. So you'll notice that 15 doesn't have a pair, because if we broke it down, it would be 3 and 5, so you wouldn't find another one. But 6 does, so they're like, well, it's 6 square roots of 15. I think this way is easier, and that's how I'm going to show you to do it. But that's how the homework is going to help you if you use view an example or help me solve this. So I wanted to make sure that you knew that's what they're doing. It requires a little bit more base knowledge than I think most people have. So let's simplify the following radicals. 45. 45 is 5 times 9, and 9 is 3 times 3. So we have a pair of 3's, and we have a 5. So the 5 does not get out. But with the pair of 3's, you've got 2 of them, which means one of them will get out. The other one distracted the guard. We don't know where he went. He's gone. Now, if you have a number in front of a square root already, when you're cleaning this up, if something else gets out, it will just continue to be multiplied by any of the stuff that gets out. So 162 is 2 times 81. 81, most people know, is 9 times 9. Again, you can break the 9 down further into 3's, but the moment you have a pair, there's no reason to go any further. So this square root of 162, a 9 gets out, but the 2 stays in. And if you have, again, multiple coefficients in front, you just multiply them together. 2 times 9 is 18, so this is 18 square roots of 2. Now, what this will sometimes allow you to do is break down different square roots until you have a common factor, and then we can do what we did with 5.4 previously. Now, you might be like, what did we do with 5.4 previously? It was combining things that had common square roots where we were adding or subtracting. Now, if you've got multiplication or division in separate square roots, what you can do is put them under the same square root and multiply them together. So the square root of 6 times 15 is the square root of 90. And then from there, you can break down your 90, 9 times 10. That's 3 times 3. 10 is 2 times 5. So you'll notice that these do not have any pairs, but there is a pair of 3's. means 1, 3 gets out. What's left underneath is the stuff that doesn't have a pair, or 2 times 5, which is 3 square roots of 10. Alternatively, if you don't want to do it this way, one of the easier ways you can do it when you're multiplying is you can break down 6 to 2 and 3. You can break down 15 to 3 and 5. And you'll notice that between the two of them, there will be a pair of 3s where 1 gets out. And between the two of them, there's a 2 and a 5 that don't have a pair, and it will still lead to the same answer. When dividing, I think the easiest thing to do is to divide them under a single square root and then simplify. 250 divided by 5 is the square root of 50. And from there, you'll do your factor tree. 50 is 5 times 10. 10 is 5 times 2. So you've got a pair of 5s. 1 will get out, and a 2, which will hang around in the square root. When you're doing operations between different square roots, you cannot combine them, but if you can break down the number to where what's left under the square root is the same, that allows you to do some combinations. And by that I mean we'll do 2 different factor trees, 72 and 32. 72 is 2 times 36, and you might be able to look at 36 and say, well, that's 6 times 6. So the square root of 72 is really equal to 6 square roots of 2. 32 is 2 times 16. 16 is 4 times 4. So you'll have 4 getting out with the square root of 2. So this is minus 4 square roots of 2. Now, if you have 6 of something and you take away 4 of something, the way that we did this in the past was, remember, you just combined the coefficients. So 6 minus 4 is 2, and it's square root of 2. The way I talked about this in the past was referred to them as brownies or cookies. You have 6 cookies minus 4 cookies, so you'll have 2 left. And I want to leave D for you to practice. Now, this is all the first homework in Unit 6 is. The second one is actually really, really easy and short, so we'll have a little addendum here about it. And that is when you raise numbers to exponents. So one thing to note about an exponent is it represents repeated multiplication. So when you see negative 10 to the second power, it means negative 10 times itself a total of 2 times. When you see 4 to the fourth, it means 4 times itself 4 times. Now, one thing I want to point out is there's a difference between this and negative 10 squared like this and negative 10 squared. Remember, in your order of operations, exponents happen first. So if you see this, you have to do 10 squared and then put a negative in front of it. When you see this, it's negative 10 times itself twice. So there's a little bit different there. They're going to try to trick you with this because it's not quite the same as that. But one situation, negatives go away, the others don't. So negative 10 squared is really negative 10 times negative 10. Negative times negative is positive. 10 times 10 is 100. 5 cubed, it's the same thing, but it's just 3 times instead of 2. And you can do 2 at a time. 5 times 5 is 25. 25 times 5 is 125. 3 and 4 are similar. One thing to note is you'll go 2 at a time here. So negative times negative is positive, but then times another a negative will go back to being negative. So that brings us to a point is when you have a negative number to an odd power, you should end up with a negative. A negative number to an even power, you should end up with a positive. So I want you to try this one and this one as well. We'll go ahead and do 5 and 6 though. Negative 3 to the 5th. Because you know the answer is going to be negative because this is an odd power, you can just bring the negative out front and then just do 3 to the 5th. So that's 3 all the way through. And you can do them 2 at a time if you want to, or you can kind of count. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times the last 3 is 243. And because the power is odd, you know that it will still be negative. 2 to the 6 is similar. You can write it all out if you would like. And you could even do it in any combination. This is really 4 times another 4. There's a lot of different ways you can do it and a lot of different ways you can combine it. 16 times 4, but any way that you do it, if you do it correctly, should end up with the same answer. And that is all the second homework really is, and that's all for this video.